So let's talk about the surface area of a solid of revolution by revolving the curve y equals x squared on the interval from 0 to 2 when we rotate that about the y-axis. Now, what's going to be different in this case is that we are revolving about the y-axis rather than the x-axis. So we're going to have to rewrite our function as a function of y. y. Well, if we consider our function y equals x squared rotated this time about the y-axis, what we would have to remember is that our curve is now going to be defined by values that would have um, strips that are related to, in length, y values. Right? So in other words, we're going to estimate right here along the y-axis. That means this is a length dy. So we need to rewrite this. Let's re-express this. This is actually going to be the curve on the interval from 0 to 2, the curve x equals square root of y. And that will be on an interval from y equaling 0 to y equaling 4, which should look pretty familiar to us if we've seen the last video. That means that we've got a function of y here, g of y, which is our square root of y, and that g prime of y will end up being 1 over 2 times the square root of y. So if we apply our surface area formula right here, which in terms of y looks like this, 2 pi times the integral of c to d of g of y square root of 1 plus g prime of y dy, we can now make our substitutions, saying that, well, our surface area will be found by taking 2 pi times an integral from 0 to 4 this time, right, because we're going along our y-axis, of the square root of y times the square root of 1 plus g prime of y squared. So that's going to be 1 plus the square of 1 over 2 square root of y. So that's going to be 1 over 4y dy. And a little bit of rewriting is going to show that our integral is now the integral of 2 pi from 0 to 4, the square root of 4y plus 1 dy. And that's going to be, by our substitution method right here, u set equal to 4y plus 1, du being 4 dy, we're going to have pi over 2, because we're going to have 1/4 of du right here, times the integral from u of 0, which is 1, to u of 4, which is 17, of u to the 1/2 du. All right, now we know what's going to happen right here. We're going to get pi over 2 times this integral, which is going to be 2/3 of u to the 3/2 when we evaluate that from 1 to 17. And making those substitutions here gives us pi over 3 times the quantity 17 to the 3/2 power minus 1. And we're done. Good luck with your homework.